In this time we are talking about measures, and let's start with converting some units. Here we have 28,000 grams converted to kilograms. How many kilograms would we get? Well, let's remember some basic stuff first. Basic stuff being kilograms to grams. So 1 kilogram is equal to 1,000 grams. 1 kilometer is equal to 1,000 meters. I think by this time you should start noticing that kilo, this word kilo, which we normally place in the front of actual unit, it actually means 1,000 from Greek. So kilo means 1,000. Basically kilometer means 1,000 meters and kilogram means 1,000 grams. We can write this down. So kilo means 1,000. We should know centimeters by this point, right? So 1 meter has 100 centimeters in it, and 1 centimeter has 10 millimeters in it, which kind of brings us to the point where 1 meter has 1,000 millimeters in it. So actually this part milli also has meaning behind it. Milli means 1,000th part of something. Means 1,000th part of something. Millimeters. 1,000th of a meter. What else do we have here? We have tons. So 1 ton is equal to 1,000 kilograms. This one is not really connected to a word like a kilo or something. And the liters, right? 1 liter has 1,000 milliliters in it. Okay, that's it. That's probably it for basics. Let's actually start doing the exercise. So what do we have here? We have 28,000 grams to the kilograms. We have to make this conversion. Let's do it. Let's do 28,000 grams equals how many kilograms? Well, what we have to do is we have to divide it by 1,000. 28 divided by 1,000 equals to actually 28 kilograms. Next we have 4,010,000 centimeters. Centimeters equals how many kilometers? Well, to convert from centimeters to kilometers, we actually have to do 2 steps, right? First, we can convert it to meters, and then we can convert meters to kilometers. So let's do that. Let's make it simple. So first, let's convert it to meters. So to convert to meters, we would have to divide it by 100. Divided by 100 equals to what's it going to be? It's going to be 401,000 meters equals to, and now we have to divide it by 1,000, which would allow us to convert this to kilometers, right? So it's equal to 401 kilometer. Okay, what do we have next? We have kilograms to grams. Let's do it. 0.032 kilograms equals to 0.032 times 1,000. So now we have 2 times because it's a smaller unit. So in case if you convert from the bigger to a smaller unit, you have to actually times the number. So 0.032 times 1,000 would be equal to 32 grams. Then we have centiliters. Okay, this is an interesting one. Centiliters. You see, it's a similar thing to centimeters, and in fact, 1 centiliter is 1/100th of a liter. So we can write this. So 1 liter equals to 100 centiliters, just like 1 meter is equal to 100 centimeters. So that gives us 30 centiliters. Oh, but we actually have to convert to milliliters. I didn't notice that. So 1 centiliter, just like centimeter, it would be equal to 10 milliliters. like this. So 30 centiliters is equal to 30 times 10 equals to 300 and milliliters. It's a bit of a rare unit, centiliters. I only see it used on the bottles of drinks, beverages. That's what it's used for mainly. But anyway, you guys have to know about it as well. Next one, we have tons. We have to convert tons to the grams. Again, we have to do the double conversion here. So 0.004 tons. Let's convert it to kilograms. This is something we know how to do. 0.04 times 1000 would be equal to 4 kilograms. And now we have to convert the kilograms to grams. So 4 times 1000 would be equal to 4000 grams altogether. Next we have liters to milliliters. Well, that's easy. 0.97 liters equals to how many milliliters? Right, the target is milliliters. So we do 0.97 times 1000, which would give us 970 milliliters. And finally, not finally, we have two more, okay? So tons to kilograms, 1.32 tons, 1.32 tons converted to kilograms. So that's equal to 1.32 times 1000 would be equal to 1320 kilograms. And then finally, 72,300 milliliters. 72,300 milliliters would be equal to what is it, liters, right? We have to convert to liters. So equals to 72,300 divided by 1000. It would be equal to 72.3 liters, like this, ladies and gentlemen. Next we have units of actually area. So area and volume, units of area and volume, they are interesting because actually, if you know, I will show you a small trick for this, which helps us in most cases. So let's say we have 1 meter. We know that 1 meter is equal to 100 centimeters. Well, you don't actually have to remember how many meters, how many centimeters squared is in the meter squared. So what you can do is you can say that 1 meter squared would be equal to 100 squared centimeters squared, like this. So what does this mean for you? What does this mean? It means that you can do the conversion. You don't have to remember all these area conversions, except for one, which is actually first here, which is actually hectares to meters squared. So hectares to meters squared, to the square meters. This one is something you have to remember. So 1 hectare is equal to 10,000 meters squared. The rest of them you don't have to remember. I will show you why. So let's do A. So A, we have 0.7 hectares equals to 0.7 times 10,000. This would be equal to 7,000 meters squared. Okay, and now let's actually do interesting stuff. B, centimeter cubed. Okay, this is one more which is kind of hard to remember. So the centimeter cubed is the same thing as a milliliter actually. A centimeter cubed is the same thing as milliliter. So 3 liters would be equal to, and there's actually a very interesting story behind it. Maybe I will make a video about it later. Why is centimeter cubed is equal to a milliliter? So 3 liters would be equal to, and we know, okay, so we know that 1 liter equals to 1000 milliliters and also equal to 1000 centimeters cubed. So 3 liters would be equal to 3000 centimeters cubed. I'm going to go a bit faster, I think, with this one. Cubic centimeters. 3000 cubic centimeters would be the good word. Next we have, sorry, this is C. In C we have 450 millimeters cubed, and how many centimeters is in there? Centimeters squared. Millimeters squared to centimeters squared. Okay, so here we can actually remember that, okay, so 1 centimeter is equal to 10 millimeters. That would mean that 1 centimeter squared would be equal to 100 millimeters squared, right? Because 10 squared is equal to 100. Yeah, so 1 centimeter squared equals to 10 squared equals to 100 millimeters squared. But you can only use this to convert one unit. Like for example, you can't do this. 5 centimeters squared equals to 50 squared millimeters squared. No, this is not what you can do. Nope. Nope, nope, nope. 5 centimeters squared equals to 5 times 10 squared millimeters squared. Like this. This is the way you should do it. So 450 millimeters squared. Now that we figured out the unit, we can actually do the thing, right? So 450 divided by 100, right? Because 1 centimeter squared is 100 millimeters squared. So we just have to divide it by 100. So 450 divided by 100 equals to 4.5 centimeters squared. That's it. What else do we have? Oh my god, so many examples. I think I will be skipping some of them. In D we have 41 centimeter cubed to milliliter. So as I told you, centimeter cubed is actually the same thing as a milliliter. 41 centimeter cubed is equal to 41 milliliter. Next one, we have centimeters squared. So we have 850 centimeters squared to millimeters squared. So remember, we just found out that 1 centimeter squared equals to 100 millimeters squared. So that means that 850 centimeters squared equals to 850 times 100 would be equal to 85,000 millimeters squared. Like this. Okay, F. In F we have, I was actually planning to do 2 topics in this lesson. Let's see if we can fit it in 30 minutes format. So in F we have 0.96 meters cubed. 0.96 meters cubed. How many centimeters is in there? Centimeters cubed. Right? So we know that 1 meter equals to 100 centimeters, and that means that 1 meter cubed would be equal to 100 cubed centimeters cubed would be equal to 100 cubed, it's a million. 100 cubed it's a million cubic centimeters. 1 cubic meter equals 1 million cubic centimeters. So 0.96 would be equal to 0.96 times 1 million, which would be equal to 960,000 cubic centimeters. Like this. And okay, I'm not gonna do another milliliter thing, and centimeters too. Okay, I think, you know what, I think you guys, if you want to practice, you can do the rest. You can do the rest, which is G, H, and I. We have all the conversions already here on this page. You can take a look, all the conversions you need, they are already here. You can take a screenshot and you can try to do G, H, and I by yourself. As for me, I have one more topic for today, which is planning collecting and processing data. Here are the numbers of catches taken by 20 cricketers during a season. Show the data in the frequency table. Okay, let's build a frequency table. Let's do it. Okay, so first we have to, for frequency table, we have to figure out what frequencies do we have. I think we have 1 here, we have, oh actually we start with 0. We have 0, we have 1, 2, 3, probably all the way to 9. So we start with 0 and we get to 9 numbers of catches. Yeah, so let's do 9 rows in the frequency table. Yeah, like this. So here we're gonna have our catches, and here we're gonna have frequency. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the way from 0 catches to 9 catches. Okay, let's count it. So 0, there's only 1 0 in here. So frequency is 1 for 0. 1, 1, 2, 3, there's 3 ones. It's good to cross them like this so that you're not gonna get confused if you skip something. So there's 3 ones. As to 2s, we have, I see 1, 2, I see 2 of them. 2 2s. Yeah, the frequency for 2 is 2. To 3, let's figure out what 3 we have. 1, 2, it's also 2 3s if I'm not skipping anything. I could be skipping something, but again, I will check that later. It's not a big deal. Okay, so 2 3s, oops, let's use this color. 4s, do we have 4s? Yeah, there's 1 4. 5s, we have 1, 2 5s, right? 2 5s. As to 6, we have 1, 2, 3 of them. 3 6. 7, there's 1, 2, 3. It's a very even distribution. We have all the same numbers, which actually doesn't really happen often. But well, that's just an example. 8, we have 1 8, and we have also 2 9s finally. 2 9s, and we crossed all the numbers, which means that probably we didn't miss anything. We can, just in case, we can add them together just to make sure that we didn't confuse anything, didn't mix anything up. Let's do a small check. So we do 1 plus 3 plus 2. That's just 1 plus 3 plus 2. I'm gonna just add all the frequencies together. Plus 2, plus 1, plus 2, plus 3, plus 3, plus 1, plus 2. This is 4, this is 6, 6, 8, 9, 11, all right? 14, 17, 20. So the answer is 20, which means that we are right because there is 20 cricketers. Okay, what else do we have? Lengths of a sample of 20 cucumbers are measured in the centimeters. The data is shown below. Show this data in a grouped frequency distribution. Okay, so what means grouped? Grouped means that we don't want to write every value from here. We want to group them in different categories, like you would do if you were measuring the height of the students in school. Right? You don't want to make a separate row for every student because all the students are going to have a little bit different heights. It's going to be like 160.2, 160.3. It's all in there, and at the same time it's not. So in this case, if we have a data like this, we have to group this data in categories. First, let's see what categories we can make, what categories are going to make sense. So we start, first let's find the smallest number. I think it's 13.8, the first one. And the largest one is, I see 34 in here. I see 34. Maybe is there anything else? No, I think it's the largest. 34.7 is the largest number. So what kind of groups should we do to make it look nice? I'm thinking, should we group them in tens, like from 10 to 20? Or maybe it's better to group them in actually, let's just group them in tens. Why not? Right? Let's just group them in tens. So we go, first group is going to be from 10 to, let's say, 19.9. Second group is going to be from 20 to 29.9. And the last group is going to be from 30 to 39.9. You see how I write 19.9 instead of 20? This way we are not going to have confusion. For example, because if I wrote from 10 to 20 and then from 20 to 30, then look at this. We would have this 20 and we would be like, okay, so where does this 20 go? Does it go here or does it go here? Right? So be careful about how you choose your groups and how you name them. What ranges do you give to your groups? Okay, let's make a table. So this is our groups, and here we're going to have a frequency. So groups and frequency. So from 10 to 19.9, let's start crossing them. We have 1, we have 2, we have 3, 4, 5. So we have 5 values from 10 to 19.9. From 20 to 29.9, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a lot, right? So 11 here, and 4. I skipped one. Look at this. I skipped something. I skipped one number, which is 27.3. So actually that's 12. So 5, 12, and then from 30 to 39 we have 3 numbers. 1, 2, 3. We have 3 numbers in here. Okay, that's our group frequency table. We can check it. So we can check it by doing 5 plus 12 plus 3, and that should be equal to 20, which it is, which means that we didn't forget any of those 20 cucumbers. Okay, that's it for frequencies. What else do we have? The table shows the masses in kilograms of some boys. State the midpoint of each interval. So let's make a separate column for a midpoint right here, right at this table. I'm going to extend each row like this. This is going to be for a midpoint. So how to find the midpoint? To find it, we have to take the beginning of the interval, and then we have to plus the end of the interval, and we can divide them by 2. Or you can kind of look at it as if we had those numbers on the scale. Let's say we have 49, or 45, 46, 47, 48, 49. Let's say we have them on the scale. So in this case, the midpoint is going to be 47. Sometimes it helps if you just imagine the scale. You don't necessarily have to draw it. And you can see that this is our middle. This is the middle for them. Or again, you can use a calculation. So it's 47 is a midpoint here. Or you can use a calculation. You can do, let's do 50 plus 54. Sorry, 54 divided by 2, which would be equal to 52. And here we would have to do 55 plus 59 divided by 2, which would give us 57. And the last one we would have to do 60 plus 64 divided by 2, which is equal to 62. This is our midpoints for every interval. And this is the last one. Here is a list of heights of plants: 4, 6, 9, 10, 5, 3, 2, 1. A lot of different heights. Find the mean, mode, median. So first let's find the mean. Mean is our kind of a typical average, I would say. It's not very hard to find it. We just have to add all the numbers. We have to add all the numbers together. So we do 4 plus 6 plus 9 plus 10 plus 5 plus 3 plus 2 plus 1 plus 8 plus 11 plus 9. It's not hard to find it, but it's kind of tiring to write it when you're trying to find it. Again, for this thing you can just use a calculator. I think it's totally okay to use calculator to find mean, especially if there's a lot of numbers. Alright, so we can just do 4 plus 6 plus 9 plus 10 plus 5 plus 3 plus 2. Can I decrease the size? I can just do it like this. I hope. Oh my god, you guys can see it now because I cropped my screen a little bit. So now you can see it. Okay, let's just do it here. Plus 3 plus 2. Oh my god, we had 2 already. Yeah? Plus 3 plus 2 plus 1 plus 1 plus 8 plus 11 plus 9 plus 4. And we have to divide it by a total. So how many numbers we have in total? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Together we have, altogether we have 12 numbers in here. Yeah? So we have to divide this by 12, this whole thing. And the answer is 6. This is our answer. I think I can take a screenshot from here. I'm going to, yeah, it's going to look like this. You're gonna see it in a second. Okay, it's here. Yeah, mean is equal to 6. Just write it as 6. Oops, I think I better just, yeah, divided by 12 equals to 6. Okay, next one is mode. So mode simply means most often. It's a number with highest frequency. The element of the selection with the highest frequency, which means the element we see most often. And this element is going to be 4, because there is 2 4s in this table. But you can say but at this point. There is also 2 9s. So what is the mode in this case? There is 2 4s, but there is also 2 9s in here. So how do we find mode? Well, it turns out that sometimes there is 2 modes. So in this case, the mode is 4 centimeters and 9 centimeters. It's totally okay to have 2 modes, maybe even 3 of them or 4. But if you don't have any numbers which are dominant in the frequency, if, like, for example, you have 1 of each number, it means you have no mode. You don't have to write all the numbers in your selection as a mode. Last one is median. So median is, it requires some action from us. Median, because median is actually the definition of median, a short definition of median is it's a middle of arranged selection. And the word which is very important here is arranged. So to find the median, you have to actually arrange all these numbers from the least number, from the smallest number to the largest number. So let's arrange them. Let's do it. So the smallest one is 1. Then we have 2 in here. How should I write them? Then we have, what do we have? 3, right? We have 1, 2, 3. And then we have 2 4s, actually. There's 2 of them. Then there is there a 5 in here? There's 6, there's no 5. No 7, there's 8. There's 2 9s actually. And there is, what else is there? There is 10. There's 1 10 and there is 1 11 in this selection. Am I right? 1 2 3 4 5 6 7 8 9 10 11. What did I skip? Did I skip something? Oh, let me see. Let me cross them. So we have 1 here, we have 2, we have 3, 4 4, 6. Oh, I skipped 5. Okay, I see that now. I skipped 5, you see? So there's 5 in here. And the middle, so there's 12 numbers in total. There's 12 numbers in total, so it's actually, the middle is going to be here, if you think about it. So there's no, the middle is an empty space. So what does it mean? It means that there is no median? No, actually it doesn't mean that. It means that we have to take two numbers which are next to this empty space, and we have to find a mean of these two numbers. So 5 plus 6 divided by 2. 5 plus 6 divided by 2, which would give us 5.5, which is our median. Okay, that's it for this lesson.